I'm going to talk about OMG modeling language standards. That is going to set the stage for things that are going to be talked about later today and into tomorrow. So what is a modeling language standard? Well, a modeling language standard is, not surprisingly, a standard for doing a modeling language, which is a language for writing models, which immediately leads you to the question, so what is a model? Well, we kind of know, but those are pretty models, but not quite what we're going to be talking about. These are models too. Now, that's not quite what we're going to be talking about either, but it's actually closer, and it's worth taking another look at this. Why do we call these models? I mean, you look at that, and that looks like an airplane, right? Now, you can pretty much tell that you're not going to be able to get inside that airplane. It's a model of an airplane, and it's a model of a train. But they're recognizably models of something, and they've got characteristics of that thing. That airplane has propellers. If you like airplanes, you know that it's a DC-3 from a Finnish airline in the 1930s. You can just look at that, and if you know about airplanes, you can tell, even though that isn't the actual DC-3. The important thing is it represents things about the thing being modeled. In that regard, these are also models. They're much more abstract models. That is also a DC-3, but that is now a picture, a blueprint of a DC-3. That's not a train, but it is a diagram of the tube system in London. The last one, well, if you're an engineer or a scientist, that actually is a mathematical model. It's called a model of the motion of a vehicle. So these are all models. They're much more abstract. They all represent certain things and have important characteristics about those things. And that's what we're going to be talking about. These are, in fact, the kinds of models we're going to be talking about today and tomorrow, and that OMG deals with in their modeling language standards. You don't point at that and say, hey, that looks like an online bank or online shopping system, but it has characteristics that are important for an online shopping system or for running your business. And that is the important thing about these models, is how you can use them to provide concrete representations of abstract things. So what is a model? A model is always a model of something. And it represents that thing being modeled. There are certain things that it represents faithfully and certain things that it doesn't. If it represented everything, if it was a copy of the thing being modeled, it wouldn't be a model, it would be the thing being modeled. The important thing is with a model airplane, we can carry that model airplane around. If I wanted to show somebody what a DC-3 looked like, I'd give them a picture or I could show them a model. It's much harder for me to bring a DC-3 with me to show people. It's the same thing. If I want to build a software system or if I wanted to design business processes, I can talk about it, but how do we actually represent it? Those are abstract concepts. I need something to make that concrete so I can communicate about it. So that's why we model. A model can promote understanding. It can be used to describe something we're studying. If you're an analyst or a scientist or even an engineer, it's very often the case that you will use models in order to take something that exists and analyze it, whether it's an airplane or a subway system or a software system. More importantly, though, for a lot of what we've been talking about, it can be used to specify something to be built or specify how to change something that exists. So you can model something that doesn't exist yet. That's actually done even with things like airplanes and cars, is building models of things that don't exist yet so we can build them. We're going to talk more about how you do that with software and with business processes, but actually, we're also going to talk about how you can model entire systems of hardware, software, and whatever. That's the important thing, is a model needs to be useful, and a useful model communicates important details about what it models. And it also, importantly, abstracts away from those things that aren't important. And that's the thing that is key. We want to be able to have ways of creating models that help us communicate. The model is not an end in itself. The model is, well, I mean, if you're a model train aficionado, I've known them sometimes, that is an end in itself. But a UML model, well, I've known some UML modelers where that's an end in itself too, but really we want a model that serves the purpose of communicating for describing an existing system or specifying what we want to do to build a new system.